Welcome to the video key for the Unit 6 take-home test. Just a quick refresher. Anything that's already written in blue is something you can check your work with. Anything that you see that's highlighted in yellow is something I'm going to do in the video with you. And anything that's highlighted in pink, it kind of looks purple, but anything that's highlighted in this color is a problem that I'm not going to give you the key for. That's one I expect you to do on your own. Okay? Make sure you're checking for the homework problem or the extra credit problems in here as well. Alright, so this first kind of section, you can check your answers. I've got a hint here for how you do number 2. Okay, go ahead and check your answers there. If you have questions on how to do any of this, go back to last semester's notes because this is all review. And if you need more time, go ahead and push pause. Alright, down on the bottom half then, I did part of this for you. I did number 5, where I put the oxidation numbers above the families that they wanted. Okay. And then for number 6, that's what we're going to do together right now. They want you to shade in the metals that never get Roman numerals. Okay, so the ones that don't get Roman numerals are the ones whose charges don't change. So family 1 metals always make a +1 charge. They do not get Roman numerals. Family 2 metals always make a +2. So the alkali metals and alkaline earth metals, they have fancy names, so they don't get Roman numerals. And then the other metals that don't are the exception block. Okay, so that's this little staircase guy in here. Silver, the 1 and 1B, that's always +1. The 2 and 2B, that are always +2. And then these 3, that are always +3. Every other metal in here, including these guys back there, have to have Roman numerals when you name them. And then number 7, it says circle all the nonmetals. And so this transition line right there, you can go ahead and draw that in. Everything over here counts as a nonmetal. Even these metalloids, we count as a nonmetal. Okay. Looking down here, I highlighted some of the key words for you. Okay, so the only time you would ever use a Roman numeral is when you have a metal, because only metals get Roman numerals, which means it has to be ionic, because covalents don't have metals. Covalents are only nonmetals. Okay, so a covalent compound would never have a Roman numeral in its name. Which type of compound may have a metal bonded to a polyatomic ion? That would be ionic. Okay. Which type of compound conducts electricity in a solution? That means when it's dissolved into electrolytes, and that's ionic. In order to conduct electricity, you need a charge, and that's an ion. Right? Ionic or covalent? Which type involves the transfer of electrons? So I taught my students, Mrs. Holmes' students, that ionic things have something from that side of the periodic table and something from this side of the periodic table. Okay, which makes them ionic, and they will transfer electrons. Sorry about that. Okay, so T for transfer is hidden in ionic. So transfer of electrons, we're going to say is ionic. And which one has the prefixes? That's our covalent names. Okay, so if both of your elements, like bromine and fluorine, are on this side of the periodic table, then it's C for covalent. And sharing is caring, so they will share electrons. And you have to give them prefixes. Okay, that's page 1. And we are cruising. Looking at page 2, we've got some more work to do on here. Okay, the first thing I'm going to invite you to do is get 2 points extra credit. So you need to write this sentence down. If on problem 15 you circle all of the covalent formulas and you write this, your teacher will give you 2 points extra credit on this take-home test. Okay, so looking down here, I'm going to go through and I'm going to circle, and I'll do it in green. Magnesium is a metal, so that's not covalent. Carbon and oxygen are both nonmetals. That makes this one covalent. Iron metal, lead metal, sulfur. Sulfur and oxygen, if we were going to point to them on the periodic table, sulfur and oxygen, I've got to make a C to point to them. That makes it covalent. They're both nonmetals. Okay. Nitrogen and oxygen, nonmetals. Aluminum's a metal. Phosphorus and oxygen, nonmetals, nonmetals, nonmetals. So those, 6 are covalent, and that means they need the prefix names. Okay. So we're going to do those yellow ones together. And when we do ionic, so I'm going to write that this is ionic, I need to remember to look for what that is. That's a Roman numeral. Okay, you can go check for Roman numerals. So iron, right here in the middle of the periodic table, needs a Roman numeral. So I'm going to call this iron blank, and then oxygen I change to oxide. like that. Okay. Iron blank oxide. So if I ask the periodic table what charge iron makes, it can't answer that question. It doesn't know, because iron's in the middle groups. But it can tell me that oxygen has 6 valence electrons, and if it needs to get to 8, that means oxygen needs 2 more electrons. So I know that oxygen makes a 2 charge, and I notice that when I crisscross, there is a 2 down there, which means iron's charge is hidden right here, a 3. So this is iron making a 3 charge oxide. Okay, for this one, oxygen makes a 2 charge, but it's invisible. So that means both of them were invisible. That's why I called this one iron making a 2 charge oxide. Okay, looking at this one, one carbon and 1 oxygen. So because these are both nonmetals, it's covalent, I need to use prefixes. So technically this should be monocarbon, monooxide, but I never start a name with mono. So I just say carbon. And then we know that there's an invisible mono right here. Okay, so carbon, and then for oxygen, in the middle of a name, I do have to say mono. So monoxide. Okay, the mono in front is invisible, but the mono in the middle is not invisible. Okay, PbSO4. Really, anytime you see a polyatomic ion, you know it's ionic. All right, and then lead also is a metal. So I know I'm going to do ionic rules for this. Lead also, being outside the exception block, has to have a Roman numeral. So I'm going to call this lead blank. And then SO4, if we look right here, is sulfate. Okay. Okay, so lead 4 sulfate. Oh, excuse me, lead blank sulfate for now. Sorry. I know sulfates makes a 2 charge. I don't know what charge lead's making right here, but I know that there should be a 2 there, and there's not. Right now it says 1/2. So if this one's supposed to be 2, then it was 2/4 and was reduced. So this lead is making a 4 charge, 1 before 5. Lead 4 sulfates. This one I do not call phosphorus chloride. All right, if they're both nonmetals, I have to use the prefixes, which should be memorized. So I take the subscript behind the P and make it a prefix in front of. So diphosphorus. P-H-O-R-O-U-S. Okay, not diphosphide, just diphosphorus. And then 4 we should have memorized as tetrachloride. I'm going to run out of room. R-I-D-E. Okay, we do always change the last 3 letters to "ide" as long as they're not polyatomic ions. Okay. Hopefully we remember ionics from last semester. Looking here, I showed you how I found my answer. Remember to take out the garbage. You're looking for 3 wrong answers in order to find your 1 right answer. For this one, Cl and O are both on this side of the periodic table right there. So that is a C for covalent, which means my answer has to have prefixes. Even if it's just mono, there has to be a prefix in my answer. This one doesn't have any prefixes, so I know that this is a garbage answer. Roman numerals. You only use a Roman numeral like this if it's ionic. So as covalent, it wouldn't get Roman numerals. Okay. Dichlorine pentoxide is okay. Chlorine oxalates. There's no prefixes there. So remember, in penta, the A is invisible. It's the same thing as pentaoxide. It's just a spelling convention. So di and penta right there. Cu3N2. The first thing we have to check is it ionic or covalent? Because copper is a metal, I cannot use covalent prefixes. Mono, di, tri, tetra, those are off limits for this problem. So tricopper dinitride is a garbage answer. All right, I can get rid of that right away. I can promise you a lot of people are going to try to name it covalently. So now we ask if it's ionic, we have to check for the I Roman numerals. And copper is not in the exception block, which means it has to have a Roman numeral, which means this is garbage. I don't want 3 coppers nitride. Okay, I want to say copper making a 2 charge nitride. So I found my 3 garbage answers, and that showed me where my right answer was. Take out the garbage, okay? Let's look at these ones. Okay, you're going to do this one on your own. You can check your work here. And we're going to do these ones together. So dihydrogen dioxide. Those are both nonmetals, and there are prefixes, so I know it's covalent. which means I'm not doing a four-step formula. I'm just taking my prefix in front and making it a subscript behind. So di are both 2's. H2O2. I do not reduce covalence. Okay? If something is ionic, we reduce it. If something is covalent, you just translate. We do not reduce. So looking over here, penta, I'm just going to translate because it's a prefix. So pentasulfide means 5 sulfurs. Monoxide means 1 oxygen. So S5O. Here, iron's a metal, so I'm not translating here. Here I need a 4-step formula. So this says iron making a 2 charge, and then oxide is oxygen. Because oxygen's in group 6, I know it has 6 valence electrons, which means it needs 1, 2 more to be like the noble gases. So oxygen makes a 2 charge. I crisscross, then I reduce and erase. That's my 4-step formula. Symbols, charges, crisscross, reduce and erase. So then these 2's would cancel out. Okay, this is a big mistake students make. Ionics, we reduce. Covalence, we do not. Okay? Make yourself a note if you forgot that. Okay. I'll give you 2 points of extra credit if you write all this down. Okay? Almost right is wrong. Okay, so looking at this one. Tin 4 sulfite, that's how I did my work. This one's almost right, 2/4. But you'd never tell someone, I'll see you in 2/4 of an hour. You'd say, I'll see you in 1/2 an hour. Okay, so almost right is wrong. Make sure you're taking out your garbage. Carbon trisulfide, that means 1 carbon and tri-sulfurs, because there's an invisible mono in front of this one. So 1 carbon and 3 sulfurs. That looks good, but I'm not looking for the right answer. I'm looking for the 3 garbage ones. This one, this person crisscrossed, which we don't do for covalent, so that's garbage. C2, it's not dicarbon, so that's garbage. C3, it's not tri and it's not tetra, so that's garbage. Alright, now I feel comfortable choosing A as my answer. Do number 23 on your own. Number 24, disulfur hex oxide. We do not reduce, we do not uncrisscross nothing. We just make it 2 sulfurs, and hex is the same as hexa, so it means 6. So 2 sulfur, 6 oxygen, that looks great. This one they got backwards. This person reduced from 2/6, they reduced it to 1/3, and we don't reduce in covalent. Alright, and this one's just all kinds of messed up. So now I can come back and say, yeah, disulfur hex oxide is that one. Alright, keep on going. Page 3. Okay, you can take a look at some of the answers that I've already got for you there. Make sure you're finishing those pink ones on your own. And then I've got a couple more extra credit points for you. Okay, if you write +2 extra credit, sharing is caring, and make sure you make that C big. Sharing is caring, that's C for covalent. Alright, that's how we did this one. Share is always covalent. Electrons dissociating, that was the weird one, that was metallic. Okay, the metals are messy, they're just going to lose their electrons, and no one's there to pick them up. Metallics only, that's when the electrons float away. Sea of electrons. Electrons are transferred in, in ionic bonds. See what I did there? You're transferred in ionic bonds. So I'm going to go ahead and pick that. Okay. I gave you 2 hints right here. Okay, 2 hints to help you do these 2 on your own, or to help you check your answer, make sure you did it right. Looking down here at the bottom of the page, I'm not really concerned that you drew these correctly. Okay, my students, I probably showed you how to do that in class. I am concerned with you being able to name it as linear, trigonal, planar, or tetrahedral. Okay, so for linear, I always just see if I can cover it up with a straight line. I can cover that one up, and I can cover that one up. So it looks like A and B are both linear. Okay, and then same thing here. This one I can't cover up with a pen, and this one I can't completely cover up with a pen. So then I need to count my outside atoms. Here I have 1, 2, 3, 4 outside atoms, which would be mono, di, tri, tetrahedral. Okay, and for this one I have 1, 2, 3 outside atoms. So I have mono, di, trigonal, planar. Trigonal and then planar. P-L-A-N-A-R. Okay, and really it makes a triangle as well, so you can kind of see that. Okay, down here I wrote a hint for you, but you've got to find the right answer. All right, we're halfway done. We're getting there. Okay, I did give you all the answers to check here, because if you cannot identify if they're covalent or ionic, there's no way you can name them all correctly. Okay, so metals are the key. I circled all my metals, and that's how I knew that those 4 were ionic and the other 4 weren't. Okay. Down here for this one, I circled little hints on these 2, but you can check your answers. Okay, push pause if you need more time on that. And then looking at this one, Lewis structure for N2. So the first thing we want to do is think what each line represents. So each line represents nitrogen, this nitrogen sharing 1 electron, and this nitrogen sharing 1 electron. So each line represents 2 electrons. Okay. So I'm going to say 2, 4, 6 on this one, and then 7. So this one's not correct, because this one shows nitrogen with 2, 4, 6, 7 valence electrons, and that wouldn't work. This one shows 2, 4, 6, 7, 2, 4, 5, 6, 7, 8. This one shows 2, 4, 6, 7, 8 on each. This one shows 2, 4, 6, 7, 8, 9, 10 atoms on each. So I can get rid of this one. Now these ones are both showing me nitrogen with 8 valence electrons. But I have to ask myself, how many bonds does nitrogen want to make? Okay. Nitrogen is in family 15, or 5A, which means it already has 5 valence electrons. And it needs 1, 2, 3 more to be like the noble gases. So in order to get an octet, nitrogen has to make 3 bonds, not 2 bonds. So this one is correct because it shows nitrogen making 3 bonds, and unlike this one and this one, it shows it with 2 more valence electrons. Okay. For this one, it's the same idea. Okay. How many bonds does fluorine want to make? Fluorine has 7 valence electrons already. It only wants 1 more. So fluorine will not share 2 electrons. It doesn't have to. It only has to share 1. So it will make 1 bond like this. So those 3 look good. And then I need to count the outside atoms. This line represents 2 electrons. So I'd say 1, 2, 3, 4, 5, 6. That's not an octet. Say 1, 2, 3, 4, 5, 6, 7, 8. That looks good. 1, 2, 3, 4. No way. So this one's great. The reason there's no dots around hydrogen is because hydrogen's in period 1, so it only wants 2 valence electrons. It doesn't do that octet rule. Okay. Looking down here, you just have to give me these 3 shapes. Okay. Hopefully we know. There's your hint for this one. Chee-dee. All right. Let's get into some more of the math now as we're working on this. Okay. You can check your answers right here on the top. All right. Again, you can kind of see in my work how I found it, so if you got it wrong. Now, I strongly recommend making flashcards for this next part. If you got them wrong, or you had to look them up in your notes, or whatever the case might be, you have to have these vocab words memorized. Not only for the Unit 6 test, but for the Unit 7 test and the Unit 8 test. Okay, you need to know that the mass of a mole is the molar mass, and its units are grams per mole, so that it's molar mass. We measure mass in grams. We measure amount in moles. So the amount of atoms is a mole, just like the amount of donuts would be a dozen. Okay, this is a mole, so it's Avogadro's number. Avocado's number is guacamole, all right? And that's also on the back of your periodic table, y'all. It shows you here that this number is equal to Avogadro's number. Okay, and percent by mass is called the percent composition. That's what we did on day 4 of this unit. Please, 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 please make sure you have those memorized for this 9 weeks. Okay? Here, you're either doing them on your own or you're checking your answers. So unless you correctly did the 4-step formula for magnesium chloride and found that it was MgCl2, you would have gotten this one wrong. If you don't show work on this, you're not getting any credit. Not partial credit, no credit. This should be your answer so you can check it. If you didn't get that answer, go back and make sure you did 1 magnesium plus 2 chlorines. Okay? We are getting close. All right. Finding molar mass again, right here. Okay, Fe2CO3 3. So this would be iron 3 carbonate, would be the name of it. So I'm going to come in and look at this. Fe2. That means I have 2 irons plus 1 carbon there, but there's 3 of them. So that means I have CO3, CO3, CO3. I have 3 of those ions, those polyatomic ions. So that's a total of 3 carbons, and then 3, 6, 9 oxygens. Okay, so I'm going to distribute the 3 times the 1 and the 3 times the 3 in there. Okay, so when you add up the mass of 2 irons, so 2 of these plus, how many did I say? 3 of these plus 9 of those. That's the answer you're going to get right here. Right? So make sure you're showing work for that. Then here we go, our last little extra credit bit. Make sure you write this down. This is for 2 points extra credit. That's part divided by whole equals 100%, or times 100. Okay? Part divided by whole times 100 will give you percent composition. You are not given this equation on the test. You have to memorize that. The part divided by whole times 100. Okay? So looking for this one, I gave you the formula, because if you did the wrong formula, everything else is wrong. 1 sulfur, 2 fluorines. Make sure you are putting the total molar mass here, and then the percent for each of the elements. No work, no credit on this. Okay? We're going to do part of this one together, though. Nickel 2 nitrate. And again, I gave you the formula. Nickel making a 2 charge, right there. And nitrate is NO3. Did I do that right? Yeah, and it makes a 1 charge. So Ni, NO3, 2. That's the formula. So when I look right here, that gives me 1 nickel. It gives me 2 times 1, 2 nitrogen, and 2 times 3, 6 oxygen. That's how you show your work. Now I have to say each nickel weighs, where's my nickel? 58.693. 0.693, which is just 58.693. Okay. Each nitrogen weighs 14.007. So 2 times that would be 28.014. Let me just double check my math though. Times 2. Okay, so my nitrogens, all of my nitrogens are 28.014. And then each oxygen is 15.999 grams per mole. So 6 times my oxygen's mass gets me 95.994. So that is my total mass of oxygen, my total mass of nitrogen, my total mass of nickel. But my total molar mass of the formula, if I add these 3 together, okay, so this number plus 28.014 plus 58.693, okay, should be 182.701. So this is what I'm going to call the whole. And these things count as the parts. Okay, I'm going to make sure I copy this answer right here. 182.701. Okay. So again, to find the percent composition of nickel, I'm going to take the part that's nickel divided by the whole mass times 100. So the part that's nickel was just 1 nickel right there, 58.693. I'm going to go divided by the bigger number, the smaller number divided by the bigger number, 182.701. Now that's always going to give me a decimal. A small number divided by a big number, like this, a part and a whole, is always going to be less than 100. So times 100 makes it a percent now, 32.1. My percent composition of nickel will be 32.1. Okay. I'm going to do the same thing for this one, where I'm going to go the part that was nitrogen, right here, divided by the whole. That's going to give me a decimal and do times 100. I'm going to do the part that was oxygen, 6 oxygens, divided by the whole, and times 100. And in order to check if you did it right, these 3 numbers should add to 100%. Maybe 99.5, but it should be almost 100%. Which means if you ever get 5,000 for this answer, you know you did it wrong, and you can check your work. Okay. Taking a look on this one, I circled that I gave you the whole molar mass. You still have to find what 2 oxygen weigh and what 2 hydrogens weigh. But go ahead and check your work there. If this is not what you got, then you need to make sure you're showing credit. And also, I can prove to you that those are the right numbers by doing this. 41.7 plus 54.9 plus 3.4. Oops, look at that, 34. 3.4 equals 100. So I know that I did that math correctly. Okay, but make sure you're showing the work for how to get those numbers. This is just for you to check and make sure you're doing it right. Same thing here. Water, remember, is H2O. So you're going to do the part that's hydrogen, H2, divided by the whole mass of H2O. That will get you oxygen. You do the opposite for hydrogen. I think I said that backwards. Do the opposite for oxygen. All right, hopefully you found all 8 extra credit points. Please make sure you are ready for this test. This is one of those tests that you do great on or you get a 40 on. So make sure you're memorizing those things, and good luck.